All right, so let's take a look at the homework from yesterday. I asked you to find the area of a triangle with the side lengths. A is 5 inches, B is 9 inches, and C is 8 inches, right? So here we have a triangle. You didn't have to draw it. It doesn't really add anything to help you to draw it, but I just sketched it out here. So we're using Heron's formula. So just as a reminder, all right, Heron's formula tells us to find the area of a triangle. We take the square root of the semi-perimeter times s minus a times s minus b times s minus c, and s being the semi-perimeter, you add up the sides and you divide by 2. All right, so that's the first thing that we have to find is that s. So we add 5 plus 8 plus 9 divided by 2. So we get 17. 17 and 5 is 22. So I get 11. All right. And just as a hint moving forward, the semi-perimeter should always be larger than all of your other sides, right? Because if we subtracted here and we ended up with one of these being negative, that would be a problem because we can't take the square root of a negative number. So plugging in the number, I have 11 times 11 minus 5 times 11 minus 8 times 11 minus 9. Oops, I mixed up B and C, but that's okay. I just swapped them there. So the 8 should be there and the 9 should be there. So I'm taking the square root of 11 times 6 times 3 times 2. That's 6. 36. 36 times 11. Oh, I got my vaccine shot yesterday. My arm is sore. 36 times 11 gets us 396. And the square root of 396 okay, so here I told you to round to 2 decimal places. So writing everything out, I get 19.8997 going on. So rounding to 2 decimal places will actually get us 19.90. And that would be inches squared. All right, so there is the area of our triangle. Any questions?
No, can we just do this for the rest of the year?
Yeah, this is pretty simple, huh? Heron's formula. All right. So we are moving on. Today we are going to discuss a topic called vectors. Now, vectors are a big part of mathematics, especially when we move into the higher mathematics and into physics. Now, when we talk about one topic that we'll keep referencing is things like speed, distance, and acceleration. Right? Those are big topics in physics and in calculus. Now, just talking about speed, let me make sure I'm saying this right. Yeah. If I'm just talking about the speed, it's just how fast an object is moving, right? It doesn't matter what direction it's moving in. I just want to know how fast is it going, right? So that's all there is. But when we talk about something like velocity, okay, that's a little different than speed. Velocity is a little more precise than speed, even though essentially, you know, if I was just using them, I could almost use them interchangeably. I can just, you know. But from a mathematics standpoint, velocity has what we call magnitude. Did I spell that right? Magnet. That's a D. Magnitude, which is the speed aspect, but we also have direction with velocity. Now that direction, we can be saying, when we talked about bearings, right? When we talked about the north, south, east, and west, we could, that could be the direction. Or if you're looking at a graph, right? So moving positively in the y direction and moving negatively in the y direction, okay, that would be velocity. Okay. Another physics concept that applies to vectors is force. All right. We have different forces acting on an object, right? So I don't know if you're in physics, but if we have, just an object sitting on a table and it's not being touched, we have the force of gravity pulling down, and then we have something called the normal force that counteracts it, right? And that normal force is from the table acting on the box or whatever we have on the table, right? Every action has an equal and opposite reaction. Gravity's pulling down, and the normal force is pushing back up. So that, we call that an equilibrium. It's not moving anywhere. I can start to push the box, and then I'm applying force in a certain direction, right? And then we have friction that goes in the other direction, in the opposite direction, force of friction, right? So we need a way to conceptualize these in mathematics. So we use what are called vectors. All right, so give me a second. So in order to represent these quantities, we use what's called a directed line segment. Now, you haven't seen this since geometry, so it's maybe been a while. But a directed line segment, it starts at a point, and I'll call it P, and then it goes off in a direction, and we end it with like an arrow there, and we'll call that Q. Okay. Where it starts, where we have the solid dot, and most vectors will have, that solid dot there, we call the initial point. And where the arrow is, where it ends, we call the terminal point. All right. We name this, and again, this is from geometry, PQ with a one-way arrow over it. And you can do the arrow with like that, but I just draw it like that with just the top part. All right, so that's what a vector is, okay? A vector is just a directed line segment that would be on our coordinate plane, right? So we'd have our axis, and I'd have my point here, and I'd have that. So this would be a vector. That's how a vector would look like. All right, let's see, what else do I have to talk about before we jump into numbers? Okay, so we can calculate, well, obviously which direction it points tells us the direction, but to calculate the distance is to calculate what's called the magnitude. Okay, the magnitude is also known as the length of the line, right? And that's just telling us, how hard we're applying force or how fast we're going. And then obviously, again, the direction is given by where the arrow is pointing. Right, so we have the magnitude. The magnitude has a different representation. So we take the segment, okay, so PQ, and then I add, they're not supposed to be slanted, they're not supposed to be italicized, it's just the way the pen was, but kind of like two absolute value signs on both sides, right? So this would be the magnitude of PQ. All right, so if you see this, it's saying the magnitude of vector PQ. And if, I just wrote out vector, if you have this symbol above it, that means that we have a vector. But I just wanted to be clear there. Now, luckily, to calculate the magnitude, we don't need any new fancy equations or anything. It's a line segment, so we just have to use the distance formula. Okay, so we'll practice that in a second. I just want to go over a few more things. Okay, when we have two or more directed line segments that have the same direction and magnitude, we call them equivalent. All right, so if I have PQ here, and then maybe I have, it's off to the side, they don't have to be overlapping each other. Maybe SR here, right? I mean, I just sketched it, but they kind of have the same direction, right? And they have the same magnitude. If we set up the right triangle, we use the distance formula, we get the same thing. Okay, they would be equivalent. So, where this comes in, let's see. Can I jump? No, not yet. All right, one more kind of definition. Okay, so we say the set of all directed line segments that are equivalent to line segment PQ, we call a vector V in the plane. Right? And so we can say that V is equal to directed segment PQ. All right, so this is lowercase, and I did make this bold on purpose. All right, we use vectors are denoted by bold lowercase letters. The most common being U and V, and then if we need a third, we'll use W. Okay, and again, those are supposed to be thicker. They are bold letters. All right, so let's, yeah, we got a little time. Let us look at all right, so let's set up, try to make a graph as nice as possible here. Trying to stare at those dots really hurts your eyes. All right, I'm just gonna put the coordinates here. All right, so we are going to we're going to show that our vectors U and V here are equivalent. Okay, so to find first, we need to make sure their magnitudes are the same. All right, so I'm going to calculate two things. I'm going to calculate the magnitude of PQ, and I'm going to calculate the magnitude of RS. All right, now be careful. How you name these, okay, does matter. The point always comes first. The arrow always goes second. All right, so here the P is first, Q, right? And we kind of follow the arrow in that direction. We start at P, and the arrow goes to Q. We start at R, the arrow goes to S. All right, so for PQ, we're going to set up our distance formula. If you don't remember it, no, I'm forgetting it. All right, that is our distance formula. So for PQ, this would be my x1. Oh, let's say this is x2 and y2, and this is x1 and y1. So I'm going to have 3 minus 0 squared plus 2 minus 0 squared. This is 3 squared, which is 9, plus 2 squared, which is 4. So we get the square root of 13. I'm going to leave it like this. Right? It's a lot easier looking at the square root of 13 than whatever it's supposed to be, 3.4 or something. I don't know. All right, then with RS, this will be my x1, y1. This will be my x2, y2. So I have 4 minus 2 squared. I'm sorry, that should be a 1. Those are my x's. Plus 4 minus 2 squared. So again, you can kind of see this gets me 3 squared. This gets me 2 squared. All right, so that does check out. The magnitudes are the same. So once we figure out the magnitudes are the same, we got to double check to make sure the direction is the same. All right, because I mean, they look like they're going in the same direction, but you know, this is just a sketch. My x and y axis might not be that accurate. You know, I accidentally skipped too much space here. All right, so I want to double check that they're going in the same direction. How can I check that they both have the same? I was trying to say it without giving you the word, but to find out if they have the same direction, I want to see if their slopes are equal. All right, so to calculate direction, we're going to take a look at the slopes. Right, and remember slopes. I don't know why it thinks I want to make a triangle. I'm not trying to make a triangle. y2 minus y1 over x2 minus x1. So the slope for PQ, I'll just say m with a little PQ there. We are going to have, oh, that's my x2 minus 0 over 3 minus 0, which is pretty simple. We get 2/3. And then the slope for RS is going to be 4 minus 2 over 4 minus 1, which again gets me 2/3. Okay, so we can say with that, all right, so we're going to sum it up by saying because PQ and RS have the same magnitude and direction, U and V are equivalent. All right, so really, it's not a whole lot of new information. The only thing that's, you know, that might get you caught up is that there's a lot of different names for things. All right, so really, you know, PQ, segment PQ, or directed line segment PQ can be renamed as U, okay? Directed segment RS can be renamed as V, all right? Just some side notes too. We can find the magnitude of the others. Actually, I don't want to mess that up right now. Okay, yeah. Actually, I'm going to hold off on that. That's for tomorrow's lesson. All right, any questions there? I don't think that's too bad. It's mostly just geometry right now.
No questions.
All right. Let's say Wednesday. All right, I'll give you a break with homework tonight since, I mean, if you want to practice doing some slope and distance, I can give you some problems. Just email me, but I'll save the homework for tomorrow. I'll give you guys a break today. All right, guys, have a good day, and I'll see y'all later.
Bye, you too.